There are two villages in the mountains, La and Ga. To communicate and work with each other, the two villages have built 3 roads to interconnect them. R1, which runs from the gate L1 in La to the gate G1 in Ga, and it can carry up to 50 tons of goods. R2, which runs from the gate L2 to the gate G2 and it can carry up to 50 tons of goods. R3, which runs from gate L3 to the gate G3 and can carry up to 50 tons of goods. As time passes, the number of goods passing between the two villages on the 3 roads increases, sometimes exceeding 100 tons. How should they transport so many goods? Is it possible to use the existing 3 roads to transport more goods? The villagers put their heads together and came up with a great idea: Link Aggregation Group (LAG). The villagers bound the 3 roads together to form a virtual avenue. The maximum weight capacity of the avenue is the sum of all 3 rows together, that is, 150 tons. A lag aggregates the gates and rows of the 2 villages. First, some gates of the 2 villages are selected and added into the lag. Then the rows connecting the gates are also added into the lag. In technical terms, lag is equivalent to port aggregation and link aggregation. A gate in the lag is called a member port, and a road is called the member link. Member ports include master and slave ports. Why do we need to define the master and slave ports? Because traffic transmission can be configured only on the master port, although the slave ports are functioning. Only the master port is visible externally. This lag is available in 2 modes, manual lag and static lag. What are their differences? For example, what if after rows R1 and R2 have been added into a lag, the 2 villages want to build another road named R3 from the gate L3 to the gate G3, but unfortunately, the villagers built R3 from the gate L3 to the gate G4 by mistake. If R3 is added into a manual lag, the lag aggregates R1, R2, and R3. Although R3 cannot be used independently to transport goods from L3 to G3, traffic will still flow over R3. If R3 is added into static lag, the 2 villages need to run the LACP protocol. By running the LACP protocol, the 2 villages will find that R3 cannot be used to transport goods from L3 to G3 and therefore shield R3. This example shows that if a manual lag is used, faults may not be detected accurately. However, a manual lag is more effective for data transfer. So in situations where LACP is not supported, a manual lag is still a good option. A static lag uses LACP, which helps detect faults accurately. What happens if 120 tons of important goods need to be transported from La to Ga? First of all, add the gates and rows connecting the 2 villages into a lag. Select the master port and configure the lag as the static lag. This virtual avenue can transport 150 tons of goods at most. Furthermore, when considering the importance of the goods to be transported, the villagers can use the non-load sharing mode to ensure the reliability of transportation. The non-load sharing mode is similar to traffic control and allows goods to be transported only over one of the rows R1 to R3. If the results obtained by running the LACP protocol in a static lag is R2, all the 120 tons of goods are transported over R2 and no goods are transported over R1 and R3, though they both remain ready to take over services if they have to. If a fault occurs on R2, the lag selects whichever road is more appropriate, either R1 or R3, for goods transportation. After these precious goods are transported, traffic control can be cancelled. When 120 tons of goods need to be transported, the 3 roads can share them. That is, each road carries 40 tons of goods. This mode is called load sharing. If a road is cut off or a new member is added, the lag automatically reallocates goods to the member roads. In this manner, villagers can flexibly maximize the utility of the roads. To conclude, the LAG technology has the following advantages: enhances road resources usage and make the best of road resources. Increases road bandwidth by aggregating roads. Improves road reliability. When a road is cut off, other roads in the same leg take over the excess traffic to prevent disruptions.